I'm going to go ahead and get started if everybody's okay with that. Thank you all for making the big long trek across the street, up the escalator, down the hall, towards the bathrooms to my talk. Nobody told me that I was going to be bathroom adjacent, so I'm glad everybody made it all the way down here for this chat. I thought I would do something a little bit different this year. My boss loves a spreadsheet, and so I thought I would present in spreadsheet format, which I assume would be something acceptable to anybody who would attend a talk talking about saving money. So if I go to 4, I think it is. There we go. Okay, so at a high level, we're going to talk a lot about a number of different things. I've tried to incorporate as many spreadsheet-related graphics as possible. But to give you a sense of scale of what Scribd, which is the company I work for and where a lot of this work comes from, is about, we have hundreds of millions of documents, which means the data and ML platform that we build and operate at Scribd has a tremendous scale. Over the last couple of years, with the advances in large language models and the utility of large language models, Scribd takes a tremendous advantage of those things. And so the cost of operating our infrastructure at this scale has become a very important part of what I obsess about and think about on a day-to-day basis. If you ever need Cost Explorer help, if you have billing, usage, or system table questions, I can answer those as well. I've spent way more time than I ever thought I would just looking at data sets coming from AWS and Databricks. So this is the one audience interactive session, or part of the session, until we get to Q&A. The whole point of saving money, I want to see a show of hands, is so that we can put money towards other things. So who would rather give money to the 1999 Time Magazine Person of the Year? That's Jeff Bezos. It was actually the first year that they called it Person of the Year and not Man of the Year. So personally, I don't want to give Jeff Bezos any money. The 2025 Person of the Year hasn't been named yet, but it might be Ali Ghodsa. And do you want to give Databricks more money? Or 2006 Time Person of the Year was you. And so the whole premise of this talk is that if we save money, maybe we'll get some more of that in our pockets, or we can put it towards something useful. Like ultimately, at the end of the day, we all have budgets, and I would rather spend budget on something that's going to move the business forward as opposed to unnecessary baloney in the data ingestion process. If Ali is Time Person of the Year, I hope Databricks gives me something special, because that would be really awesome that I predicted it. So at a high level, a lot of data pipelines are kind of simple. It's you take data from somewhere, you bring it in, you land it typically in, if you're following the medallion architecture, that's your bronze layer, it's structured, it's not refined, it's not clean, etc. And then you do interesting stuff with it. One of the big things that I've pushed the Databricks team on in the past, and I've worked a lot in the open source community around, is this first step, getting the data in, is not interesting. That's taking bytes from one place and putting them into another. Once you get to the processing or the transformation or joining data sets, that's where things like Apache Spark, the Databricks runtime, Photon, etc., become really interesting. And so if you think about what we spend our money on in the Databricks platform, we Scribd, you all, spend a lot of money just getting the data there. And a lot of the work that I'm going to be presenting on is trying to remove that step because it's not differentiated. It's not interesting. Getting data into a Delta table format or into an Iceberg table format is pretty simple. It's not something that Apache Spark is well suited to do. It's not something big distributed compute is well suited to do. And you can do it in a much lower utility or much lower footprint than Apache Spark typically requires to operate. A lot of my numbers are very accurate, so everything is 100% true and correct in this presentation, so you can quote me on that. So let's talk about Delta Lake as a format. Delta and Iceberg are really what I'm mostly concerned about these days. There are other lakehouse formats. I'm not interested in them. You may be interested in them. But at its core, Delta Lake is a it's Parquet data files in orange, as indicated by my helpful legend, and a transaction log that sits in object storage next to it. The reason that this is important, and by the way, you should get this wonderful book. I contributed a chapter, but a bunch of other people did much more interesting things in that book. If you want to know everything about Delta that there is to know, you should get that book or get Databricks to give you the book. There's actually a free PDF of it on Scribd because there's a free PDF on delta.io. So you don't actually have to buy the book. Saving you money. Excellent. So The transaction log is the interesting part about Delta. The data files could come from anywhere. And that was one of the big realizations that I had a couple of years ago when I started to see Parquet become the standard format that a lot of data systems produce. And once you know that a lot of data systems produce Parquet, then the challenge becomes, well, how do I dress up the transaction log to match that? How do I gussy it up so that it's now queryable as a Delta table and I'm not doing a list or a scan across S3 to ingest my data into a open lakehouse format? Iceberg is fairly similar. I'm not a super big expert on Iceberg. I've never written anything about Iceberg. But functionally, they are similar. There's more metadata. There's a catalog with Iceberg. There's other things. There's other stuff at the sort of table format with Iceberg. But functionally, they are the same in that there's data files, which are kind of who cares where they come from. And then there's table metadata around them. So these approaches that I'm going to talk about will apply for Delta and Iceberg as well. So at Scribd, when I started to look at the work that we had and the systems that we were interacting with, what I found was a lot of things are actually already Parquet capable. I don't have a good buzzword for this, but they can produce Parquet. And when most of the things are in Parquet already, spinning up a Spark cluster to take that Parquet and turn it into differently shaped Parquet or differently written Parquet with different tags or whatever isn't really all that interesting. So we already get it in Parquet in almost all cases. Now there are some outliers, and I can talk about those if I have bonus time, where we have systems that might produce CSVs or JSON. If you're working with a large language model, a lot of these are large language model as a service, like an OpenAI or a Gemini or a Databricks model serving or batch Bedrock. A lot of those will produce line delimited JSON, which is not Parquet. The savvy listener may have noticed. And getting those into a Delta table format requires a little bit more work, but it still doesn't require a Spark cluster. Getting data in is the most simple thing that we can do. It's where we do querying and joins. That's where we should be spending the money and leveraging distributed compute that we have in Apache Spark. So this is a small selection of the data sources that we have at Scribd. If you're in AWS, as Scribd is, as many, many companies are, there's a lot of things that already produce Parquet. When I talked with our AWS account team about Aurora, I discovered in 2023 that Aurora produces Parquet. I was like, whoa, this is the craziest new feature. Stop the presses. Let's stand up at reInvent and talk about this. This is incredible. And then I actually went in preparing a different presentation and I looked, it's actually been around since 2020 and nobody told me. You can turn Aurora tables into Parquet with nothing more than a button click if you have console access or a step function or something like that. We'll talk a little bit about that more in a second. Then there's another product called Kinesis Data Firehose, or formerly known as Kinesis Data Firehose. We've dropped the Kinesis. It's now just Data Firehose. And Data Firehose, for the last number of years, has supported what they call output conversion. And so you can take a streaming, if you're not familiar with Data Firehose, it's just, it's like a Kafka. It's a thing that you stream bytes into, and at the other end, you can get those messages out. You can just flip data conversion on, or output conversion on, for Data Firehose, and you get Parquet in an S3 bucket of your choosing. I'll talk a little bit more about the cost implications to that, but if you have smaller amounts of data, Data Firehose with output conversions means you can take any real-time source of data and blammo, presto bango, you've got an append-only Delta table with pretty much one click. SQS doesn't give you Parquet, but I got something for you for that. Airbyte, and you should go down and talk to them. I did see them on the expo floor this morning. Airbyte is an open source tool. If you're not familiar with it, you should check them out. They have an S3 destination, which we use, that produces Parquet natively. If you're on Google Cloud, you can just take any input and dump it into Parquet. If you're on Azure, you can take any input and dump it into Parquet. You may be noticing a theme. Kafka. Kafka's kind of a pain in the ass for a lot of reasons, but in this one in particular, there's tools with Confluent that you can get. There's tools that you can get from your cloud provider that will produce Parquet-ish things out the other side of a Kafka topic. Scribd built one called kafka-delta-ingest. I did mention this up front because it's not super relevant. Scribd created the Delta Lake bindings for Rust. The whole reason we created the Delta Lake bindings for Rust was to build kafka-delta-ingest, which is an open source tool which reads data from Kafka and dumps it into a Delta table. We can do better than that. In 2025, we can do better than that. But there's not really a great way to take data out of Kafka other than running something that's going to consume, basically do a while true, take message, take message, take message, right to Parquet. In the Delta users Slack, at least once a week, someone comes in and says, hey, I've got a bunch of Parquet. How do I turn this into a Delta table? And usually, the other contributors might be tired of me saying this, I have a solution. And it's to not write this in Python. It's not to do anything too esoteric or interesting in your job, per se, but to use this Lambda, which I created, and I highly recommend it. It's very quality code. It's called oxbow. And the trick with oxbow, and why I want more people to start using it, is it relies on bucket notifications. So when a Parquet file lands, it will go add that transaction log. So it builds on top of Delta Rust, and it adds those transaction log entries as data comes in into your S3 bucket. The really interesting thing when I talk to a lot of data engineers is event-driven data pipelines is something that is a little bit beyond where most people are thinking about what's possible. But when you step back from the table format, when you step back from how we traditionally build Spark jobs, orchestrate them with Airflow, et cetera, a lot of clouds give you bucket or object notifications. They will tell you when data is created. And then if all you need to do is add a little transaction log on top of that, you can build a very, very lightweight event-driven system that scales very horizontally to ingest large amounts of data. Because the thing that's doing the delta write, in this case, is whatever's producing the Parquet. Or it's doing the data write, excuse me, not the delta write. But the little bitty Lambda just says, I know that this file exists, and it should be in the transaction log. That's the zen and art of oxbow. It's incredibly simple. It's probably, all said and done, it's maybe 400 or 500 lines of Rust, which makes it extra cool because it's in Rust. But it's very, very simple because the problem domain is actually quite simple once you remove the data file write from the equation. And so here's building a presentation in a spreadsheet is surprisingly difficult. You'll see as we go through these sheets, because there's no slides, that I started to figure out a little bit better ways to diagram things. But this is an ASCII diagram because I couldn't figure out a better way. But in essence, we have an external service. What is producing the Parquet data? Irrelevant. If you use Fivetran, Fivetran will produce Parquet. If you use Airbyte, if you use a lot of cloud-native tools, I'm sure there's a myriad of integrations down on the expo floor which do produce Parquet in some form or fashion. You just have to land that into an S3 bucket. Somebody somewhere has to write the data. And what makes this cheap is you already are running that something else to write the data to Parquet. Then we receive a bucket notification in SQS. This is the cloud native part of the talk. And then all oxbow does is it's triggered by that message coming into SQS that says file exists here. It does a little bit of intelligence to infer the path to the delta log, because that's a pretty important part of creating the append. And then it writes to the delta table. What makes this really interesting to me and why I get like super jazzed up about it is when we think about data ingestion, a lot of people think about rows per second, messages per second, gigabytes per second, like these very, very large numbers. Most of the oxbow lambdas that exist that I have deployed are running on 1 vCPU or 0.5 vCPU. And so you have a delta table that is being produced by something with 1 vCPU of compute, and something else like an Aurora or a Kinesis Data Firehose that is producing the Parquet files. And so your typical thinking of throughput for a data ingestion pipeline gets completely thrown out the window because something else is performing that right, and you don't have to think about that. You think about what comes after it lands in your bronze layer. I should note, before I move on from this, the append part is important. Concurrent transactions on delta tables is a little bit of a tricky subject in S3. We've had a lot of development there. But if you have data files that are landing, but you have some other process that is trying to do merges, upserts, deletes, et cetera, you're going to screw up your delta table. Don't do that. The medallion architecture plays a pretty big role in the success of this approach. If your delta table is append only, and you can set a delta table property called append only equals true, then you only add rows to this table. And then your silver and gold layer, that's where you're going to be doing those joins and those merges, those things where your big distributed computation are going to be valuable for you. And so if you have a organically grown data platform like Scribd does, you might not always be able to make this hard line rule of this is append only, this is your bronze layer, only this one ingestion pipeline is gonna write to that. In that case, you're kind of in a tough spot. It's difficult to fix that without, or approach that from the oxbow or like this event-driven architecture without changing your underlying data model to, I would say, more appropriately adopt bronze, silver, gold, etc. The Aurora export part is a little bit interesting. Earlier this year, I gave a webinar with, it was supposed to be with my colleague Kuntal. He was actually sick that day. And so I had to present our slides to one person presenting both those slides. Getting data out of Aurora is pretty simple, but structuring it in the appropriate way is a little bit tricky. If you think of your classic delta table, let's say you're partitioning on a date stamp or you're partitioning on like year or something like that, your tree is my delta table slash year equals 2025 slash star.parquet. Aurora does not give two shits about that. Aurora is going to dump a huge mess of Parquet files into an S3 bucket and say, good luck, have fun. And so there's another Lambda this is also in the Oxbow repo if you're interested, that we use called the restructure Lambda. Fortunately, Aurora does give you some predictable prefixes on its output, so you know that your landing zone slash 0 slash, I don't know why they put the 0 at the beginning, but there's a 0 there, slash 0 slash my database cluster name dot schema slash table name slash star.parquet is what you have to then sort of translate into your Parquet or your Delta table structure in some form or fashion. And so with the Aurora export flow, the restructure Lambda has a regular expression. If you're scared of those, then be warned. You have to use a regular expression to fish out the data from that prefix you need and translate those to your Delta table path. The nice thing about having that tool in your toolkit is this, in our architecture, actually does our S3 bucket replication sort of by default as well. So we don't replicate from the landing zone into our Delta table. We have it write to a different S3 bucket. And the reason we don't let Aurora write to our data lake is because, as I mentioned, Aurora is just shooting infinity Parquet files of various shapes and sizes into an S3 bucket, and we don't want that in our data lake. And so we're also using this restructure Lambda to take those Parquet files and make sure that they're going in the right locations, and that only those files, not any of the temp files, the underscore files, or the other things that the Aurora export process might export, goes into our data lake. Let me make sure I got everything there. There's the Oxbow part as well. I couldn't see it way over there. Because I'm presenting on a spreadsheet, I can't see it down here, so I've got to look at the screen like everybody else. But with Aurora export, this is probably the most complicated way of most complicated workflow for getting data that comes from an external Parquet system that I've worked with. I'm sure there are other more complicated ways to do it. But in our architecture, there's some step functions involved. There may be another Lambda. And at the end of the day, personally, I will prefer a couple of step functions in favor of a number of Spark jobs orchestrated by Airflow in a DAG that needs to trigger on some interval. Because one of the really great things about this approach is you can do two things with Aurora. You can export directly. You go say, Aurora, export these tables into Parquet. Or you can take a snapshot that you should already be producing on a semi-regular basis, hopefully nightly, if not more frequent, and you just export the snapshot to Parquet. And so you have two ways to get data out of Aurora, but in our case, we're taking the snapshots that we were already producing, and our step function helps us identify when those snapshots are finished being created by the Aurora backplane, and they can be exported to Parquet. All right, Kinesis Data Firehose. I have not used output conversion in Anger in production, so caveat about a lot of things that I'm about to say. But with output conversion, you can just say, take this stream, I think that's the name, the topic equivalent in Data Firehose, and produce Parquet from that. There's some nuance to that configuration on how big your Parquet files are, or how frequently you might need that like flush interval, or whatever your batch might be from a streaming data pipeline standpoint. But one thing that is really important to understand about output conversion is you pay for it. AWS will never let you get away with something for free. And so if you have, let's say, 1,000 messages per second flowing through Data Firehose, that costs, $100. That's not actually what it costs. It costs $100. I don't know how much it costs. Output conversion on top of that usually costs like another $100. And so for high throughput streams, I have walked away from systems before they went into production because the cost of output conversion with a very high throughput stream, we're talking like hundreds of messages per second, is just too expensive to where it no longer justifies the cost of using Data Firehose. That's where a Kafka or a system where you have more provision throughput is probably going to serve you better, unless you're tightly wound to Data Firehose. But if you already have Data Firehose and you already are incurring this cost of pushing data into it, enabling output conversion is a pretty simple from an opportunity cost, a labor cost standpoint, to just produce those data sets into S3, and then Oxbow says, hey, there's a new file, let's go do that. Now, Airbyte is something we have deployed in production, but we're a little bit behind. At the booth downstairs, they can tell you all about the wonderful new things that have come in the more recent releases of Airbyte. I have not used those, but Airbyte is a really great tool. It's open source, which means I like it more just by default. But one of the really interesting things about Airbyte is for a lot of data pipeline work that we're doing, especially around ingestion, it's not really that interesting to begin with. It's like we've got Google Ads that have to come, Google Ads data, Google Analytics data. We've got this third-party provider that provides data here. We've got to go get it through a REST API, blah, 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 blah. It's really boring work that nobody likes to do anyways. Airbyte gives you a lot of that connector marketplace to pull those in into this sort of intermediate layer that they have, and then plumb that through to the S3 destination, the Azure, whatever storage destination that you might have, and that supports the Parquet output. One of the big criticisms, and I went down to chat with them about Airbyte this morning, one of the big things that we've hit a snag with is large data sets. So looking at how Airbyte was implemented, I thought it was simultaneously very, very cool, but also terrifying. Because the way that it works is everything is JSON, and it's piped, like literal Unix pipes between two processes where one is writing your input data, say from Google Analytics, to JSON line delimited messages that it pipes to standard in of your output connector. And so if your input source is hundreds of gigabytes of data of Parquet coming from somewhere or from some other third-party data source, it's going to have to serialize all of that to line delimited JSON and then go through the drinking straw over to the output connector and re-serialize Parquet. So it was hugely inefficient. They've since made some changes to the protocol, and this is why I was asking them about downstairs, or I guess it's over there, is they now have a way to get large files sort of out of band from one side to the other. And so if you're taking large data files from an external system, that approach will probably allow you to take very large data sets out of one thing and put them into Parquet format in S3. So my biggest con for Airbyte, I have been assured, has been fixed, which is really exciting. But as I said, it's open source. Open source is great. So I want to talk about kafka-delta-ingest because this is what sort of started our journey at Scribd. My colleague Christian Williams gave a presentation, I think in 2022. And in 2022, we cut our data ingestion costs by switching from a Spark-based workload to a Kafka-delta-ingest-based workload by 90-ish%. We saw a tremendous reduction in data ingestion. But the way that Kafka-delta-ingest works is we have to sort of pin a running container of Kafka-delta-ingest to a partition in Kafka, because we've got to make sure that we get every message. Ordering is not guaranteed in Kafka, except on the partition level. And so you can only incrementally move your consumer if you're looking at the partition. And so we threw out this big Spark infrastructure, and we brought in these Kafka-delta-ingest Rust-based containers that were running. But then we started to blow those out to where we were auto-scaling these container groups out to run a large number of containers because we had so much data that we had to have kind of container per topic or container per groups of topics. And one of the big downsides of this approach is, if you're not familiar with the Kafka architecture, is your table might have one consumer group. And whenever there's a consumer group change or your subscription changes in Kafka, all of your consumers in that consumer group need to rebalance. And so what we found is that as we scaled up our data through kafka-delta-ingest, or through Kafka and then kafka-delta-ingest, it wasn't the writing to Delta, it wasn't the writing to Parquet, it was actually just churn of auto-scaling up and down to meet our needs that was causing the most, I would say, problems in our production environment. And so some of what led me down this path was trying to fix this problem. Kafka-delta-ingest just has too much consumer group churn because of the architecture of Kafka and the architecture of Kafka-delta-ingest. So if you can avoid running a process to consume data and just let something else write it, that's certainly my preference. One of my colleagues here, Anish, I'm going to call out Anish, if you could wave at everybody, say. So you can ask him questions. He's got to talk as well at Data Summit. He, or his team, and my team built another thing called SQS ingest because I was, really excited to do all cloud native things all the time. And Lambda is a big part of that. And so what we identified was we had some workloads that needed Kafka. They needed that extremely high throughput. We couldn't put them in Data Firehose. But we had a lot of data sets that were streaming, but they were streaming like in the dozens of messages per second or dozens of messages per minute. Like we're talking about data volumes that you could solve with a bash script. And we had a number of those. We had a tremendous number of those. We probably had, of our total topic count, I would say 75, 80% of data streams were actually in this low throughput categorization. And so what we did is we ripped those out of Kafka for a lot of reasons, and we started to put those into SQS. And one of the nice things about SQS is you can trigger your Lambda to just when messages arrive in SQS, it gets triggered with the messages that were in SQS. And then what SQS does, unlike oxbow, it does the actual data write. So oxbow just knows that a file exists and updates the Delta transaction. SQS ingest is much more like Kafka-delta-ingest or your traditional data ingestion pipelines in that it actually performs a data file write. Something that I learned along the way is a Lambda function has a 6 megabyte argument invocation limit. And so that means every byte that the Lambda was taking out of SQS could be at most 6 megabytes of data. And if you think back to our transaction log, that meant that we were creating at most a 6 megabyte uncompressed Parquet data file and a transaction log at the same time. And so for a number of these streams, we saw that our transaction volume exploded. Our transaction volume exploded, but our data volume really wasn't that large because the model of Lambda-based invocation really wasn't cutting it for the amount of data that we were trying to push through. We talked about this with our AWS team, and one of the interesting things that was suggested by Jared Wiener, who is our SA at AWS, I'll give him credit because this was his idea, was just to go grab more messages. And I felt really dumb when he said that because I'm like, God, that is so simple. I should have thought of that. You can also just go retrieve messages from SQS. Of course, it's just an API. And so what we actually use SQS for, is this sort of buffer more messages setting, where the Lambda invocation triggers that data is available to be read. And then once it receives, we'll say our 6 megabytes of data, but then it says, I can run for, let's say I have a timeout of 2 minutes, I can run for 60 more seconds to grab as many data or many rows as possible from SQS and then do the data file write. And so that's how we've actually deployed it and solved this transaction log volume problem, is we just use the SQS Lambda invocation as a signal and then go grab a bunch more data. And the really novel thing about this is that means when there's no data there, the cost of our ingestion pipeline is 0. Which means we also were able to enable teams to just say, like, if you want a data pipeline, you need to give me an ARN that can write to an SQS. And then you get a data pipeline. We no longer have to be involved in capacity planning in a lot of cases. We no longer have to be involved in cost discussions for new data pipelines. We can just say, if you want to get data from here to there, just give us an ARN that can write to SQS. And then if they're writing data, we incur costs. If they're not writing data, if they forgot, or they decided against it, or the experiment failed and they turned it off, there's no cost. There's no ongoing cost. And that is a pretty big deal for a company like Scribd, where we want to experiment as quickly as possible. And not all of our experiments really go anywhere. So this is not real numbers, just to be clear. I'm not allowed to share real numbers. I will get yelled at. But when I think of our two data ingestion flows, we've got streaming data and then we've got online application data. The data coming from Aurora, something like that. When we went, as I mentioned, to kafka-delta-ingest, we went from a sort of Spark-based approach to streaming data. We cut it tremendously. We cut that cost tremendously. When we brought it to SQS ingest or Airbyte, or not Airbyte, excuse me, Oxbow, we cut it even further. Like to take a data ingestion pipeline, cut the cost by 90%, and then 2 years later, cut the cost of that by 90%. I felt really good about that. It seemed like a really great idea. What was even better than that to me is the OLAP import became sort of a non-issue. We don't really run any infrastructure aside from a couple lambdas to import our OLAP data. We used to run replicas where we could sort of scoop, if you're familiar with scoop, S-Q-oop, effectively scoop all of our data every night in a big Spark job. We would have our replicas auto scale up. We would copy terabytes and terabytes of data into our data lake and then shut everything down. It was huge operational complexity. There's a handful of lambdas and a couple step functions now involved in that. And so the operational cost being what it is, that small yellow line, is less impressive to me than the fact that we have a system that no longer requires maintenance. We no longer are maintaining database replicas. We're no longer worrying about replication lag. We're no longer worrying about any of the infrastructure standing up Spark jobs, orchestrating, this has to happen, this has to happen, this has to happen. So I would say the opportunity cost that we were spending on that system was much higher than the operational cost. And switching to just having Aurora give us Parquet let us drive both of those costs down, which was really important. I have 8 minutes and 30 seconds left. If you have questions, and to give you a final graph, if your questions are formed as a question, they will almost certainly be answered. If they are formed as a comment, they might not be answered. Highly unlikely that I'll answer those. But if you have questions, I'm happy to take them. Thank you for your attention, and thank you for stopping by.